Lesson 6.3 takes us a different direction. So 6.1, 6.2, we talked about vectors. Okay, 6.3, we're going to talk about, we're leaving vectors behind for the moment. We're going to talk about parametric curves, okay? So the idea of parametric curves is we're still talking about x and y, but we have an extra variable thrown in, and it's called a parameter, okay? So a little bit of information up top. The graph of the ordered pairs x, y, where x is f of t and y is g of t. So both x and y are defined in terms of t, which is that third variable, or what we're going to call a parameter, okay? And these f of t and g of t, they are functions defined on an interval, a through b, of t values, and it's called a parametric curve because we're using that parameter. The equations are known as parametric equations, and the variable t is a parameter. Okay, that's the whole idea, behind parametric equations. And then the interval a to b of t values is the parameter interval. But keyword, you keep hearing me say, right? Parameter. So what we're looking at is these equations are going to be two separate equations that come together to make one equation, essentially. Okay? We're going to practice here. We're going to look at how to graph one by hand. Then we're also going to look at how to take the two equations and combine them into one equation. And then also, we'll also look at how to do these on the calculator at the end of the lesson tomorrow. Okay? So, example 1. For the given parameter interval, graph the parametric equations. And the equations we're being given, can you see them right here? X equals t squared minus 2, and y equals 3t. So this is an x and a y equation that go together. They're in terms of parameter t, but together they form one xy graph, or xy equation. Now, we're going to do this 3 different times on different intervals. So as we look at A is asking us to take our parametric equations there, and we're going to graph it on the interval when t is between -3 and 1. Now, anytime we don't know what a graph looks like, and we don't have really any information, I'm always going to suggest that we try setting up like an XY chart. Okay, but here's the deal. We're not going to set up just an XY chart. X and Y are both defined in terms of t. So, and I'm going to try and save lots of room for my graph. So up here, I'm going to have a t, x, y chart. They're providing me the t's. What t's are they telling me to use?
-3.
No. I need numbers right now.
-3.
And?
And 3 and -2.
Nope, just stick on A.
Oh, -3, 1, and 1. -3, 1.
Okay, but what does this whole statement mean? This doesn't mean just -3 and 1.
T is between
T is between -3 and 1. So what other values can we include here? Because I need more than just 2 points to graph this.
-3, -2, -1, 0, 1.
Okay. In other words, we need values. This is saying t is between -3 and 1. So go down to -3, but then we can also use -2, -1, 0, and +1. Okay, so understand, when it says t is between -3 and 1, it includes all numbers. I mean, if we wanted to get really fancy, we could throw decimals in too. But I think, usually the idea is as long as you have the whole numbers, you can connect the dots, essentially, right? Okay, so those are the t's we're going to use based on what they told me to use. Now, how do I find my x values?
You got to do t squared minus 2.
Right. Okay, x is defined as t squared minus 2. So we're going to take each of our t's and plug them in. So -3. -3 squared minus 2. So -3 squared is 9. 9 minus 2 is 7. I'm going to go ahead and do all the x's first. negative 2. So negative 2 squared minus 2 is? Yeah, 4 minus 2 is 2. Negative 1 squared minus 2.
Negative 1.
Negative 1 squared is 1, and then 1 minus 2 is negative 1. 0 squared minus 2,
Negative 2.
and 1 squared minus 2. 1 minus 2 is negative 1. Okay, repeat said process. This time with the y's. Y is equal to 3t, so take each t value and multiply by 3. So when t is negative 3, y is 3 times negative 3, negative 9. When t is negative 2, y is
Negative 6.
negative 2 times 3, which is negative 6. When t is negative 1,
Negative
3 times negative 1, negative 3. When t is 0,
0.
y is 0. And when t is 1,
3.
3 times 1 is 3. Okay. We were asked to graph this. So we are specifically looking at, what do I want to use here? We are specifically graphing the xy values here. Okay, so you're not going to physically see the t values on your graph. You're just graphing the xy's. And xy's are just ordered pairs, yes? So I'm going to try and set my graph up here. As you set your graph up, kind of pay attention to the needs of this graph. In that you only have to be able to go 2 left, if I recall. But you have to be able to go as far as 7 right. You only have to be able to go 3 up, but you have to be able to go 9 down. Are you seeing what I'm saying here? So I'm going to kind of make my graph longer on the bottom and the right. That is a really...
The thing is just a graph. This rest of the space we can use just for graph.
Well, we still have to do B and C.
Yeah.
But for A, yes, all we have left to do is the graph. So any space you have left on A is your graph space. Sorry, I thought you were thinking like the entire rest of this.
No. I thought it was
Y goes 9 down and 3 up, which is why I'm lopsided here. So you have to be able to go 2 left, 7 right. You have to be able to go 3 up and 9 down.
So we're just plotting x, y, right?
We're just plotting points. This is the easy part.
Okay.
This is what you've been doing since like elementary. Yes?
Yes.
Okay. 7, negative 9. Right? 7. 9 down. 2, negative 6. Right 2, 6 down. Negative 1, negative 3. Left 1, 3 down. Negative 2, 0. Left 2, up or down 0. Negative 1, 3. Left 1, up 3. What's it look like?
Nike swoosh.
I laughed because my morning class said candy cane. I totally see the Nike swoosh. Let's talk about what it looks like in terms of familiar mathematical graphs that we often graph. What?
Parabola.
Part of a parabola? Okay, so it's not all of the parabola because we're just using those specific t values. But, oh, dang it. Don't go past your dots.
It's like a dot to dot.
It is like a dot to dot. And the reason I'm saying don't go past your dots is because these are the specifics of how t was defined. Our parameter t specifically went from negative 3 to 1, so our graph does not go past those points because we graphed the 2 endpoints there. Okay. You got that out of the way.
Yeah.
Now, what's B change up?
The t values.
What do you notice about those t values?
They're between negative 2 and 3.
Mm-hmm. Now, I love to cheat off myself. Not cheat off other people. No, there's a difference. Cheat off myself. How can I cheat off myself here?
But you already got negative 2, negative 1, 0, 1.
Can we use these values from previous?
Yeah.
Why not? Then we've already got -2, -1, 0, and 1 t-values. So the only other t-values we have to do?
2 and 3.
2 and 3. So I'm going to continue my chart, so to speak. So I have a txy chart here. And all I'm putting in it are the 2 and the 3 that I don't have yet. Am I making sense?
Yeah.
Okay. When t is 2, what do you know?
2 squared minus 2 is 0.
2 squared.
Or 2.
2 squared minus 2 is 2.
Stop it.
When t is 3,
9 minus 2 is 7.
3 squared minus 2 is 7. Okay, let's do y's. When t is 2,
6.
6.
3 times 2 is 6. When t is 3,
9.
9.
3 times 3 is 9. So now, when we graph this,
You don't want to get this.
we're going to use these two pieces, yes? So we're going to use the xy's from previous and our new xy's.
Graph it.
And you're leaving out the 1xy. I'm going to set up a similar graph. I still have to be able to go 2 left and 7 right.
But you have to go up 9 and down.
I have to go up 9 and down 6. Because we're not graphing that none, they're 9. Not that it's not still there, but it's not part of this.
Okay.
Okay? What do we say? It's up 9 we have to be able to do? Okay.
Yeah, so go down.
Well, I still have to be able to go down 6 though, too.
How far left? Did you go left?
Okay, we have to go left 2. If you look at your x values,
And then right 3.
right 7.
7. Oops. That's what she said. That's what I said. Did you not hear me right?
Left or down 6.
That's what I heard. Thank you.
And did that this morning too. Okay, up 9.
So,
Okay, you ready?
almost.
Mm-hmm.
Right 3 down.
So, when t is -2, we're going to go right 2, down 6. Gosh darn it. I'm in that no man's land. I hate when that happens. Okay, I'm not. Why won't you let me graph? I feel like it should let me graph here.
Is that a -6?
Hmm?
Is that why it's supposed to be a -6?
The one I'm graphing right now?
Uh-huh.
Yeah.
Okay.
Okay, I cannot get 2 -6 to graph. I'm going to have to make it like... Mine's going to be a little high. You're just going to have to deal. Okay, -1, -3. Left 1, down 3. -2, 0. Left 2, up or down 0. -1, +3, so left 1, up 3. Then in our new ones, right 2, up 6. And finally, 7, 9. Okay, what do we have?
A better look at parabola.
Okay.
Not quite there yet, so
Closer
closer.
to more of a complete parabola, except we lost part of the bottom but added part of the top. Okay. What about C?
We already have everything we need.
Give it everything we need. Yes?
Yes.
C asks us to do -3 to +3. So, set yourself up a graph. The extremes, right? It's still the left 2, right 7, but it's up and down
9.
9. And so now for this one, we are using all the pieces. So, did you get started without me?
Yes.
Yeah.
Good. Right 7, down 9. Right 2, down 6. Left 1, down 3. Left 2, up or down 0. Left 1, up 3. Right 2, up 6. And right 7, up 9. And
We have a full parabola.
we got the full parabola. Technically, it does not, you still don't have arrows,
Right.
but at least it's a symmetric, appears to be full parabola. Yes?
It's a basketball court.
Okay, so Doug is saying I just drew my 3-point line. Is that what you're saying?
Yes.
Okay.
Because the 3-point line ends, it doesn't keep going.
True. Ends it out of bounds, so. Okay. That is a little bit about how to graph these parametric equations by hand. Okay, they give you 2 equations. You can find your x's and y's based on picking some t values or being told some t values, which is what was the situation here. Okay. The next part, which I think we will focus more on tomorrow, okay, is how do we take the given 2 equations and eliminate the parameter so that we can identify what this curve is. Like, as we look at this last one, let me backtrack for a moment. Did you know that was going to be a parabola?
No.
No. I mean,
I can't tell because of the
I guess, had I asked you guys, what do you think this is going to be when we put these together? I could have seen parabola coming up because
square.
you see the square. But did we know exactly what was going to happen? Did you know it was going to be a sideways parabola? Definitely not, So what we're going to look at is how we take these 2 equations, this x equation, this y equation, that are both in terms of t, put them together into one equation that just has x, y. So we're going to eliminate the parameter. And then we're going to have an equation x, y that you'll be able to look at and be like, oh, hey, I know what that graph is. And so we're going to do that. That's what we're going to work on. Our idea here is going to be pick an equation, pick one, and solve it for t. Officially, it doesn't technically matter, although there's usually an easier route and a more difficult route. Okay? So when we could probably do the first part here. Which equation would you solve for t? Probably y?
2 minus t.
Okay, because we're not going to have to divide by anything. We're not going to create fractions into our problem, yes? We might have to work with fractions eventually, but, so our first step is going to pick one of the equations. I'm not going to say which, because it's just going to vary. And solve, I'm going to say solve an equation for t. And I've already been told, which one do you guys want to solve for t?
Y.
Y equals 2 minus t. How are you going to solve that for t? No.
Oh.
How do we solve it for t?
Subtract y plus t. Oh wait, t equals y minus 2. Or y plus 2. You're going to subtract the 2 from the negative, or from t to the other side.
So if we subtract the 2,
Negative t equals.
I'm going to have y minus 2 equals negative t, and then divide by negative 1, we'll have negative y plus 2. We'll come back to that tomorrow.